All right, so circle theorem number 8 says the length of the two tangents to a circle from an external point to the 2 points of contact on the circle are equal. Guys, only 2 tangents can be drawn to a circle from an external point. So if you have a circle and you have an external point, only 2 tangents can be drawn to the circle from this external point. And what this theory is saying is that the length of these 2 tangents from the external point to the point of contact, the length of those 2 lines are the same. That's what that is saying. All right. All right, so what are the implications? So in the diagram above, R and P are the 2 points of contact of the tangents QR and QP. So QR and QP are tangents drawn from an external point Q, and the length QR and the length PQ, they are equal. Now look here, guys. So R is a point of contact. P is a point of contact. OP is a radius at the point of contact. So OP is a radius at the point of contact. So it must be at right angles to the tangent. OR is a radius at the point of contact. So it must be at right angles to the tangent. You see the angle here and the angle here, they are supplementary. So if this is alpha, and this is theta, alpha and theta must add up to 180 degrees. They are supplementary. And its simple reason is that the angles in a quadrilateral must add up to 360 degrees. So if two of them are, if the angle at P and the angle at Q add up to 180, the angle at O and the angle, if the angle at R and the angle at P add up to 180, the angle at O and the angle at Q must also add up to 180. All right, so the implications, see it here, the angle at O and the angle at Q add up to 180 degrees. The angle at R and the angle at P, they are both 90 degrees because the radius at the point of contact is at right angles to the tangent. Now, if I draw a line now connecting R and Q, remember now QRP, the triangle would be isosceles triangle. The angle here, theta, and the angle here is also theta. The angle between the tangent and the chord at the point of contact is equal to the angle in the alternate segment. If the angle here is theta, the angle here is 2 theta. The angle at the center is 2 times the angle at the circumference. All right. And essentially, those are the implications for circle theorem number 8, which essentially says that the length of the 2 tangents from an external point to the 2 points of contact on the circle, the lengths of those 2 tangents are equal. 9 is actually a given. 9 says line joining the center of the circle to the midpoint of the chord meets the chord at right angles. All right, this is something that I know, and it's something that you all should have known as well. And I tell you why, because you would have learned this when you learn about the isosceles triangle. The 2 equal sides meet at the apex, and opposite from the apex is the base. The 2 base angles are equal. Everybody know that. But I would have also told you If you draw a line from the apex to the center of the base, it's going to meet the base at right angle. It's actually the same thing here, because this is an isosceles triangle. Actually, the same thing. If you draw a line from the apex to the middle of the base, it must meet the base at right angles. So it's actually something you came across already. So 9 says a line drawn in the center of the circle to the midpoint of a chord meets the chord at right angles. And I'm saying that 9, the idea of 9 is something that you came across already. All right, and now this is going to lead us to our last two examples.